Great. It'll speed me up nicely, all right? Volume of a sphere. Volume of a sphere is 4 over 3 pi r cubed, which would be 4 over 3 multiplied by pi multiplied by 0.3 cubed. Can you give me that answer to 3 decimal places, please? 0.113 centimeters cubed. All right. The sphere is made of pure gold. Each centimeter cubed of pure gold weighs 19.3 grams. Find the number of grams in the sphere. Okay, it's going to be 19.3 multiplied by. First of all, is it going to be lighter than 19.3 or heavier than 19.3? Because you haven't even got a centimeter cubed, do you? You only have that much. So you're going to multiply it, and the answer should be smaller than 19.3. What do you get? 2.20 grams. Yeah. Are we got that? Okay, let's keep going. It is known that approximately there's this many atoms in 197 grams of pure gold. Find the number of atoms of pure gold in the sphere. Are we expecting more atoms or less atoms in our sphere? This is a really big number. Are we expecting a smaller number or a bigger number to be in our sphere? Because 197 grams contains that much. Do you get what I'm saying? So here's what you're going to do. You're going to say 197. You might want to change your calculator into science mode, by the way. 197 grams equals 0.6010 by 23. Okay. Now, you can find out what 1 gram is, couldn't you? Or you could find out how many what size is our sphere again? Oh, sorry, yeah, here it is here. How many 2.2s? How many 2.2s fit into 197? How many 2.2s fit into 197? How many times smaller is my sphere when compared to 197 grams? So divided by 197 divided by 2.2. 89.54. Just call it 545, okay? So if you divide by 89.545, you will get how many atoms are in this. So go mode, shift setup, science mode, science 0, 1 second. Then get your 6.02 multiplied by 10 to the power of 23. You're going to divide that number by what? Well, you're going to divide it by 89.545. Reason being is your sphere is 89 times smaller than 197 grams. So you're going to divide that by 89.545. So two significant figures would be 6.7 by 10 to the power of 21. 6.7 by 10 to the power of 21. Does anybody need me to go over that one more time? All right. You guys can help me out through this. Each section is 3 meters wide, no bother. Trapezoidal rule. H over 2, everybody remember? First plus last, 2 times the remainder. Okay, what's the H value this time? 3 over 2. What's our first value? 4. Our last value? 8. 2 times the remainder is going to be quite the calculator trick here. So what was it? 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. Let's see if anybody agreed with each other. What happens when you lob all that into the calculator? What should you get? Did anybody else get 145.8? All right, we'll just agree that's what we get, okay? So I'll just advise you to just use your calculator later on and see what you get. Is that okay? Would everybody feel confident they can put that into a calculator? If you aren't confident, here's what I suggest you do. I suggest you do the yellow section first on its own. After you've done the yellow section on its own, add it to the blue parts, 4 and 8. And once you get an answer for that, then multiply your answer by 3/2. And it might make things a bit easier to do in 3 parts instead of 1 part. Your call. So everybody's happy with 145.8? Okay, let's move on to the next one. The area of the same field was re-estimated by applying the trapezoidal rule again. This time the width is 4. The wider you make it, the more inaccurate it is. Okay, because when you do the trapezoidal rule, you're joining up like this. So the wider you make it, see the way the gaps are bigger? See the gaps that I'm underestimating and overestimating them? The narrower you make it, the more accurate it is. Okay, so that's the first thing. Now, let's go again. But we don't know the height, do we? We don't know what x is. So we're doing the same rule again. What's the h value this time? 4/2, first plus last, and then 2 times the remaining. Okay, let's try this out. All right, h/2 is 4/2, which is very simply 2. Everybody happy with that? 4/2 is 2. First, 4 last, 8. 2 times the remaining, so 6.4 plus x plus 6.2. Now here's what I would do with you guys, okay? Here's my suggestion. Why don't you guys add up these parts on your own, right? So get your calculator out. I want you to add up the following parts. The parts I have in yellow. Just want you to add the yellow parts first, okay? And while you're there, just add the 2 blue parts together as well. So you're limiting down what you have to write in the next line. It's going to be 2 times 12 plus 2 times blank. What did the yellow parts add up to? 25 point. And then x there. Now we have an easy rule here. Multiply in by 2. What you get? 51 plus 2x, yeah? 51 plus 12. Multiply that by 2. 126, and this is 4x, yeah? What did they say the answer is equal to in the question? 145.6. Now we're really close. So 4x equals 145.6, take away 126. In science mode, so shift, setup, normal 1. 19.6, divide that by 4. 4.9. Everybody happy with x value 4.9? What be a good way of checking if your answer is right or wrong? And an easier, cheaper way of thinking if you're right or wrong. If you go to the very top, you're shorter than 6, but bigger than 4. Does our answer qualify? And that's a really cheap way of knowing if you're right or wrong, isn't it? Without having to go all the way in. Like in the exam, you're going to be shorter time, aren't you? So you know, oh look, that looks pretty damn good. Like more than likely I'm correct. Does that make sense? Yes. Yeah, absolutely. All right. Okay, we have a cone. There's 14 of them. They're in pairs. The height of each cone is equal to the diameter of the base. Okay, so diameter and height. So h equals diameter. Diameter in turn equals 2 times the radius. Implies the height is 2 times the radius. Oh, brilliant. So 2 times 2.25 is what, guys? Everybody happy with the height being 4.5 meters? Brilliant. Slant height. Oh, great. So slant height is, that's 2.25 down here. Vertical height, 4.5. Slant height, we don't know. What formula do we use for this? Right, how many people got that part out? Right, so you use Pythagoras theorem. And what you get, 4.5 squared plus 2.25 squared. And you should get 405 over 16, or, yeah, I can write that down, 25.3125 square root the answer. What you get, Ben? 5.03, yeah, take that. Now, we're on B now, are we? Mm-hmm. In order to maintain the steel's reflective sheen or shine, the surface is polished regularly. Oh God. The curved surface area of each sculpture, 14 counts. Find your answer correct to 2 decimal places. Why do I not need to worry about the total surface area in this question? Why not? Why do I not need to worry about the total surface area and only the curved surface area? Can anybody tell me? It's essentially, they're joined in the middle. So, see here? The circle isn't exposed, is it? Because you have another cone sitting directly on top. A cone on its own, when it's just on its own, you have the curved surface area, which will be in red, and then you have a circle that will be in green, and that's why you get pi r squared for the circle and pi r l for the curved surface area, and you add them together. But in this case, the cones are sitting on each other, which means that the green area is never exposed. Does that make sense? So you don't have to do the green area. Yeah, if you want, just for a minute. All right. So, what we're going to do is just do pi RL. Is that the area of a, is that the area, is it? And then what I do with pi RL when I'm done? Multiply by 14. So pi times 2.25 times 5.03, and then multiply that by 14. And what do we get? $497.77. Meters squared, yeah. All right. 497.77. All right, guys, next one. 497.77 meters squared. Lads, will 1 litre of polish do the job? Lads, why will 1 litre of polish not do the job? 12 is considerably smaller than 497. How many 12.25s will fit into 497.77? Was it 41 points? Well, I multiplied, meant to be divided. You got 40.634, so 40 points, correct to nearest litre. Like 40 litres won't get the job done, so I'll need 41 litres. In a test, I might just write down the decimal anyway, just to have it there, just to show the examiner I did it properly anyway. So 41 litres, okay with you guys? A container of polish contains 5 litres. Well, that's a 9, because we're going to have to buy 45 litres, aren't we? That makes sense? So we're going to need 45 litres, which is how many containers? Each container contains 5 litres. 9 containers. I round up to 45. Now, costs in euro. So what's 9 multiplied by, is that Australian dollars? So what's 9 multiplied by 110? That's 990 Australian dollars. Now, Key question. Which number is bigger, Australian dollars or euro? Australian dollars will always be a bigger number than euro when you have the same amount. So are we expecting an answer bigger than 990 or smaller than 990? We're expecting an answer smaller than 990. You have two choices. You can divide by 0.68, and if you divide by 0.68, what will happen? It will get bigger, and you don't want it to be bigger. So what happens if you multiply by 0.68? It gets smaller, which is what you were looking for. €673.20 or 673. So we multiplied by 0.68. All right, you guys? Yes. Just always identify which one is the bigger number. So if I said dollars, if I said €1 is American dollars, is let's say 140 American dollars. You know that the American dollars is always a bigger number than euro. So whatever you do, you got to get a smaller number. And there's only ever two options: divide or multiply. Shh. All right. C. Shh. The diagram, not the scale, shows the net of the outer surface of one of the cones of the sculpture. It is a sector of a circle of radius length 5.03 meters with arc length P, angle theta at the center. Find P, the length of the arc of the sector. Give your answer correct to 2 decimal places. Anybody remember how to do this? Now, 2 pi r will give you the answer of the full circle, which means you can't half it because it's not half a circle. Okay? So, here's the issue. The question is theta over 360. That tells you what fraction of the circle you want. Multiply by 2 pi r. All right. Now, find the length P. Find P, the length of the arc sector. Give the answer correct to 2 decimal places. All right. The diagram shows the net of the outer surface on the cones. All right. Here's the deal. What did we learn from? What did we learn from our cone the other day? That this red distance here. See the bottom circle? This distance here, the circumference of the bottom has to be the same as what? Circumference of the bottom has to be the same as the outer edge. Okay, and lads, look, keep looking. These two yellow parts here, where are they located? That yellow part there and that yellow part there. That's what happens when you fold it up. You get what I'm saying? The slant edges are the yellow parts and the circle on the bottom is blue. Now we know what the radius is earlier, don't we? What's the radius here? 2.25, and you guys were correct earlier. You're just going to use 2 pi r. You're going to find the blue circle, and the blue circle is the same as the blue arc. Everybody cool with that? Tough question. Same as the net, the fan part of the net. Okay, so what do we get there, guys? 2 multiplied by pi multiplied by 2.25. What you get for that? 14.42. 14.14. Okay. Shh. Meters. Just a length, isn't it? Everybody cool with that? Okay, guys. Next thing has to be done. The next question is tough. Okay. Now you can do 2 possible ways. What would be the? I'll show you 2 different ways of doing it. What would be the length of the full circle? 2 pi r. Would you agree with that? And what radius am I going to use for this circle? Just get me that answer there. Just in meters, 2 decimal places if you can. So what would be the area of the full black circle there? What? 31.67. 611. 6-0. Sorry, my fault. First time I've never understood you, John. Now, guys, what fraction is the blue part compared to the whole part? So 14.14 divided by 31.60. Put the answer to the calculator, let me know. Or what decimal part is it? Would you agree it's just below halfway? It's 0.4475. Would that be all right with you guys? Now, a full circle is 360 degrees. So what would be 0.4475 of a full circle? So multiply your answer by 360 and it'll tell you what angle you were looking at. The angle you were looking at was 161 degrees. How do I know I'm right by looking at the diagram? It's below 180. How do I know it's below 180? It's smaller than a straight angle. Does that make sense? Smaller than a straight angle. So 161 degrees. That's one way of doing it. The other way of doing it would be to use the formula that you're given. The formula you were given is theta over 360 multiplied by 2 pi r. It's in your tables. Gave you an answer of 14.14. First of all, what's 2 pi r in this question? Talking about the yellow part here. The blue arc is got using the big circle. So what's the radius of the big circle? 2 times pi times, anybody? 0.3, yeah. Theta is here and 360 is here as well, isn't it? And that equals 14.14. All right, you want to get theta on its own. See the theta here? What's multiply on the left is divide on the, so what's going to be in division mode? 2 pi and the 5.03. The 360 is in division mode on the left, which will make it multiplication on the right. Throw all that into the calculator and you'll still get 161 degrees. Okay, whichever way you want. Just did two ways, just because I can.